Hello everyone, this is Cameron Smith from TechLogix here today to go through another one of our 15 to 20 minute webinars, this one on ensuring integrity with fiber optics. This is part of the larger course that we offer for both CD and Bixby. This is a great course if you want to learn how to make sure your installation, your fiber optic installation is going to work fine without issues, and if you do have issues, how do we troubleshoot those? We're going to spend 15 to 20 minutes going through this topic. And I want to remind everybody, this is a short webinar. If there's things that we're not covering that don't make sense, such as the different types of fiber, the different acronyms we use, or the different terminology we use, we've got a lot of good online resources. We're happy to point you in the right direction and get you in some other courses that are going to explore some other topics. I also want to mention that everybody's muted. If you do have questions, please type those into the GoToWebinar widget. It's a little software pop-up that should be on the right-hand side of your screen. We'll get to those questions at the end of the session. And this is also going to be recorded. So afterwards, everybody will receive a link to the recording. Feel free to share that with other folks in your organization. No problems there. So without further ado, let's talk about fiber, and specifically, how do we program and how do we wire a system that's going to operate? Well, there's a couple of different things that you want to make sure that you're thinking through before you actually start pulling some cable. Make sure the design and the installation is going to work fine. So the first and the most basic thing is there existing cable or is it a new installation? Are we doing a retrofit or are we pulling into a new building? This is pretty important because if you are going into a retrofit and there is fiber that's already existing in place, you want to make sure that you're using the same type of fiber. If it's blue, odds are it's going to be multi-mode fiber. Multi-mode only splices and couples to other multi-mode cables. Single mode, this one's typically yellow. Single mode only splices and couples to single mode cable. So if there is already fiber in the wall, in the rack, installed in the project, use the same type of fiber. And this is a big part of the other courses that we offer. We really walk folks through this topic to make sure you're designing and you're installing properly. Now also, how's the cable going to be used? What are you going to do with it? This will help you determine the type of connectors, the amount of fiber optic strands you need, and really a lot of this is based on the different devices that you'll be connecting to the fiber. Different electronics have different types of connectors. Now, while you can adapt those connectors, you can buy crossover cables and little couplers and little adapters and things of that nature. It helps to specify the cable, the connectors correctly prior to the installation. Where will the cable be run? We want to make sure that we get the cable jacketing right. Things like outdoor ratings. Is it going to be armored? Is it going to be directly buried in the soil? All of these things will help us as a manufacturer get you the right product. It will also help you really understand the different options and constraints based on the different fiber optic cable types. How long will the run be? How far are we trying to send signals? And this one's pretty important too, and we see this issue play into a lot of the cable construction that we do. There are two types of fiber, as I mentioned, multi-mode and single mode. Anything that's going over about 1,000 feet, you need to think about single mode fiber optic cable. Single mode is designed for long distance distribution, and far too often we see folks think that fiber is fiber, and they'll pull a multi-mode cable, or at least try to pull a multi-mode cable further than 1,000 feet. It isn't going to work very well. So if you're looking at a cable run, you're going more than 300 meters or 1,000 feet, you got to think about single mode fiber optic cabling. And then finally, how's the cable going to be managed? What are you going to do with it? How are you going to mount it? How are you going to manage all of those little fiber optic strands that are inside the overall cable? Are you putting a service loop into the installation so you have a little bit extra as you're maintaining and you're servicing this in the future? All of these things play into the conversation. Now, we're going to turn our attention at this point to some of the most important concepts when you're designing a system. And that concept's the topic of a link budget. Link budgets are incredibly important, especially if you're using your fiber optic cabling for audio video distribution, things like HDMI, things like AV over IP. The link budget, in calculating that link budget and sticking to that link budget, this is going to help make sure your system's actually going to operate in the real world. And frankly, a lot of folks who work with fiber and have worked with fiber for years, they don't fully understand the concept of the link budget. So here's the easiest way to think about this. The link budget's comprised of two things: a loss budget, which is the anticipated amount of signal loss on a cable run. So just like a copper-based installation, twisted pair-based installation, right? We can look at that cable run. We can look at how many splice points, couple points, patch panels, all the different things that are in line, and we can calculate an amount of loss on that cable run. And the second thing that comprises the link budget is the power budget, or how much loss can your devices tolerate before they don't work anymore, right? All your electronics, whether they're network-based or video-based, they can take a certain amount of loss, but there comes a point at which too much loss means no signal or no quality of signal, things don't work anymore. So if we take this loss budget, compile it with the power budget, this gives us that overall link budget. And the reason I say a lot of folks who've worked with fiber for years don't understand this concept or really don't appreciate this concept is because they're using their fiber for networking. And in a network environment, that power budget, so the amount of loss the electronics can tolerate, is pretty high. Frankly, you can be tolerably okay at terminating a cable and you can still get a network installation to work. That is because think about how network traffic operates. You have packets of data traveling back and forth through the cable, right? And historically, those packets of data are traveling through a copper cable where you don't have instantaneous communication. You have a little bit of latency in the signal, meaning you can have packet loss or packet loss and then packet regeneration and correction. This means that an improperly terminated cable will just slow down the signal, okay? Network equipment will tolerate anywhere from 11 to 22 dB of loss. That's a significant amount of loss before you start to see those electronics not work anymore. Video doesn't work that way. So while your customer may not notice a slightly slower network speed because we're having this packet loss and this packet correction, they certainly will notice when they turn on their projector and the video flickers in and out. That is what we consider a catastrophic failure because there is no packet correction in a video distribution environment. You either have signal, you have handshake, you have sync, or you don't. And for that reason, what we see, the power budgets that we see when we're dealing with video, such as HDMI extenders or maybe AV over IP extenders, 3 to 5 dB, significantly less than that network equipment. You have to be pretty good at what you do to make sure these signals are going to operate properly. So where does the loss come from? It's actually not the fiber optic cabling itself. We see that the glass and the polymers used in modern fiber construction, they're really good at what they do. They're really high quality. They're really pure. Those lasers transmit very cleanly through the cable. It's actually the splice points, the connectors, the couplers. That is where we're seeing our loss. So we can look at a real world installation, and what I have on the screen right now, this may look like a living room or a theater, but really think of this as a video distribution application, whether you're doing residential, and this looks very familiar to you, or you do commercial. This could be a boardroom, a meeting room, a house of worship, a classroom, an auditorium. We're taking video from a rack. We're moving that video over bulk fiber through a wall plate, through a pre-made patch cable, and into the projector. Okay, we're distributing video. And because we're distributing video, we know we have a power budget of 3 to 5 dB. Okay, we want to make sure we don't exceed 3 to 5 dB in loss. We can look at this installation, the connectors, the cable, the wall plate, the patch cord, and we can calculate out the amount of loss, and we can calculate that out, and it comes to about 1.3 dB. So if we can tolerate 3 dB of loss, we should be operating around 1.3 dB in loss. This should be golden. This should work just fine. So once we get our cable pulled, everything's installed, we can test that cable run. We can get out our handy optical link test kits, our meters, right? Plug the meter into the cable run, and we can actually calculate that loss out. We can meter it out. It's when we find out that, uh-oh, I'm not operating at 1.3. I'm operating at 3 or 5 or 10. I've got more loss than I should. What's going on? The first thing you're going to want to do is get out your VFL, which is basically a laser, visual fault locator, and you're going to want to test your connectors. You're going to want to test continuity in the cable run. VFL is a very low-cost, handy tool to really help you do that basic troubleshooting. But I will tell you that significant portion of the time, folks find out, yep, the connectors are put on there properly, everything looks pretty good, but I'm still calculating out more loss than I should have. And this is why clean connectors are so incredibly important. So let's take a step back. Let's think about this. Optical cable is sending light waves. We are sending lasers through a glass or polymer pipe out through lenses into electronics that will read those light waves. If we have dirty connections, those lasers aren't going to fire cleanly. You're going to have loss, okay? And this is why it's so incredibly important to keep dust caps in place as long as possible. Those dust caps on your connectors, on your electronics, even on the cables and the connectors themselves. This is going to make sure everything stays clean. But here's the reality, right? We don't work in clean rooms. We work on construction sites. When we're installing equipment, there is drywall dust in the air. There's pollen. There's oil from our fingers. There's barbecue sauce from lunch. There's all kinds of different things, contaminants out there that can get onto those optical lenses, that can disrupt those signals. And this is why one of the best investments you can make, your company can make, is what's known as a pen style or click style cleaner. This is a small, inexpensive tool, usually costs around $65. This will clean 800 to 1,000 fiber optic connections, both the ports and the male connectors on the cables. This will take your loss down significantly if you have any obstructions on those lenses. Basically cleans them. There's a puff of air, a little wipe of the lens, you're in good shape. For $65, it's one of the best investments you can make, especially if you're doing anything with a retrofit where you're going in, you're working with cable that's already in place. So the final thing that I want to mention, and if you do have any questions, feel free to start thinking about those, typing those into the GoToWebinar widget here. Again, this is a short little webinar, just covering a quick little topic here on fiber optics and continuity, ensuring that integrity. But I do want to leave you with this. Fiber cable has come a long way in terms of manufacture and quality. Modern fiber optic cables are built with either polymers, basically plastics, that are incredibly strong, or they're built with bend-in sensitive glass, meaning a glass core that is very, very pliable. You can wrap it around your finger, it won't break. These modern fiber optic cables, they're easy to terminate, they're very durable, they're very strong. You can do this, you can handle this, and you can watch some videos online that'll show you how to terminate and work with these cables. But here's the catch. If you're going into a retrofit, you may not be so lucky. There may be fiber optic cabling that's been installed and it does not feature this bend-in sensitive glass or these polymers. You got to be careful. And part of it is you got to be careful because you don't want to get glass shards in your clothing, on your skin. It's an irritant, but more importantly, you want to make sure you don't damage that installation. And you can't compare the bend ratings of newer cables to the bend ratings of older cables. You've got to handle it more carefully, because you're, in a way, lucky if you overly handle an older fiber cable and you break it, because then you know it's bad. What tends to happen is you get a crack in it, you damage it. And just like a windshield, over time, that crack expands, that cable falls apart. You really want to avoid that from happening. So be careful with older cable, handle it carefully, assume that it's going to have a bend radius of 1 to 3 inches on it, and you'll be in good shape. Well, I want to thank everybody for attending today. I know it's a quick little webinar and a quick little topic with fiber. If you're interested in learning more, please visit our training page on the TechLogix website. We have a lot of good pre-recorded topics, especially around fiber optics, variety of different things. We also have longer courses that are certified for industry credit. You can get FIXI renewal units. You can get CEDIA renewal units. You can learn a lot about fiber. If you do have specific questions, I don't see any questions coming in. That's usually a good sign. Feel free to reach out to us at info@tlnetworks.com or give us a call in the office. We're happy to help walk you through these designs, through the technology, help move your company forward in the fiber optic category. Again, thank you to everybody for attending today. I hope you have a great rest of your afternoon.